Hello everyone, welcome back to my channel, Mambalut's Math Tutorial. Last time we had already discussed all about the arithmetic sequence. We will now proceed to the next kind of sequence, which is the geometric sequence. But before that, let us recall what is a ratio. A ratio is the indicated quotient of two mathematical expressions. So we have an example here. Find the ratio of the second number to the first number. Number 1, we have 4 and 20. So to get the ratio, which is represented by R, we have 20 divided by 4, which is equal to 5. Example 2, we have 100 and negative 50. So R is negative 50 divided by 100, which is now equal to negative 1/2. Example 3, we have x squared y and x cubed y cubed. So to get R, we have x cubed y cubed divided by x squared y. So dividing these mathematical expressions, we get x y squared, since we are subtracting the exponents of the same variable. Example number 4, we have 1/2 and 1/3. So the ratio is 1/3 divided by 1/2. In dividing fractions, we just need to multiply the reciprocal of the denominator. So this becomes now 1/3 times 2 over 1, since 2 over 1 is the reciprocal of 1/2. And then multiply both the numerators and the denominators, we get 2 over 3. So our ratio now is 2/3. Example number 5. We have negative 2/5 and 3 over 10. So R is 3 over 10 divided by negative 2/5. Multiplying again the reciprocal of the denominator, we have 3 over 10 times negative 5/2. So multiplying the fractions, we get negative 15 over 20, which can be reduced further into negative 3/4. So R is negative 3/4 in example number 5. Example number 6. We have square root of 3 and 5 square root of 6. So the ratio is computed as 5 square root of 6 divided by square root of 3. In order to solve this radical expression, we need to rationalize. And in rationalizing, we need to multiply this expression by square root of 3 over square root of 3. So multiplying now, we get 5 square root of 18, which is the result of the square root of 6 times square root of 3, over square root of 9, which is the result by multiplying both the square root of 3. And this is now equal to 5 times the square root of 9 and 2, in which 9 and 2 are the factors of 18. And then over the square root of 9, which is equal to 3. So, look in the numerator that we can get the square root of 9. So, we have to get this out into the radical expression. So, we have now 5 times 3. And what's left in the radical is the square root of 2. So, divided by 3. And we can now cancel out 3. So, what's left is 5 square root of 2. So, the ratio in number 6 is 5 square root of 2. Let us now define what is a geometric sequence. A geometric sequence is a sequence whose terms has a common ratio. For example, we have this activity. Identifying a geometric sequence. Number 1. We have 1, 2, 4, 8, and 16. So we will divide the terms to know if it has a common ratio. So 2 divided by 1 is 2, 4 divided by 2 is 2, 8 divided by 4 is 2, and 16 divided by 8 is 2. Therefore, this is a geometric sequence which has a common ratio of 2. Example number 2. We have 1, 3, 6, 10, and 15. So dividing the terms, we have 3 divided by 1 is 3, 6 divided by 3 is 2, 10 divided by 6 is 5/3, and 15 divided by 10 is 3/2. So observe that they don't have the same ratios. So this is not a geometric sequence. Example number 3. We have -2, 6, -18, 54, and -162. So dividing the terms, we get 6 divided by -2 is -3. Then we have also -3. 54 divided by -18 is also -3. And the last one is also -3. So this is a geometric sequence with a ratio equal to -3. Example number 4. We have 100, 50, 25, 25 over 2, and so on. So we need to divide the terms to know the ratios. 50 divided by 100 is 1/2. 25 divided by 50 is also 1/2. And 25 over 2 divided by 50 is also 1/2. Therefore, this is a geometric sequence with a ratio of 1/2. Example number 5. -18, -10, -2, 6, and so on. So -10 divided by -18 is 5 over 9. -2 divided by -10 is 1/5. And 6 divided by -2 is -3. Since they don't have the same ratios, therefore, this is not a geometric sequence. Example number 6. We have square root of 3, 3, 3 square root of 3, 9, and so on. So dividing the terms, we have 3 divided by square root of 3 is equal to square root of 3. 3 square root of 3 divided by 3 is square root of 3. And 9 divided by 3 square root of 3 is also square root of 3. Thus, this is a geometric sequence with a ratio of square root of 3. Let's have activity 2. Find the next two terms of the following geometric sequences. Number 1, we have 2, 6, 18, 54, and 162 blank and blank. So, we need to get the common ratio first before we can get the next terms. So, in here, we have a common ratio of 3. So, therefore, to get the next term, we will multiply 162 by 3, and that is equal to 486. Multiply another 3, we get 1,458. Example number 2. We have 320, 160, 80, 40, blank, and blank. So the common ratio here is 1/2. So therefore, we divide the terms by 2. So 40 divided by 2 or times 1/2 is equal now to 20. Multiply another 1/2 and that is equal to 10. Example number 3. We have -3, 2/3, -4 over 9, 8 over 27, blank and blank. So the ratio here is -2/3. So therefore, we need to multiply the term by -2/3 in order to get the next term. So multiplying 8 over 27 times -2/3, that is now equal to -16 over 81. Multiply another -2/3, and the next term would be 32 over 243. Example number 4. We have 3 square root of 2, 12, 24 square root of 2, blank and blank. So the common ratio here is 2 square root of 2. So we multiply 2 square root of 2 to 24 square root of 2, we get 96. Multiply again 2 square root of 2, we have 192 square root of 2. Let's have activity 3. A mine worker discovers an ore sample containing 500 milligrams of radioactive material. It was discovered that the radioactive material has a half-life of 1 day. About how much of the radioactive material will be present after 5 days? So from this problem, we have our first term as 500, since the radioactive material contains 500 milligrams. So since we are talking about a half-life, therefore the common ratio here is 1/2. So after 1 day, we divide the radioactive material by 2 or multiply by 1/2, so we get 250. After 2 days, multiply again by 1/2, so we get 125. After 3 days, multiply by 1/2, we have now 62.5. After 4 days, multiply again by 1/2, we get 31.25. And after 5 days, multiply again by 1/2, we get 15.625. Therefore, 15.625 milligram of the radioactive material will be present after 5 days. Now it's your turn to answer the modules. I hope you learned something from our discussion today. And of course, like and subscribe for more videos. And hit the bell, of course, for notifications. Thank you so much for watching. At your service, Ma'am Balot. Mwah mwah.